Welcome to this lesson. In this lesson, we are looking at calculus differentiation. How calculus can be applied in business. So we first of all look at the principles underlying calculus. We saw a few examples and we look at how we can apply them in business. So let's start with calculus differentiation. So we start with differentiation. That is calculus. So the whole thing about calculus explain the change in one variable as a result of change in another variable. So if we have y is equal to 2x, this y will be known as dependent variable. Then x will be independent variable. What this means is that y can only change as a result of a change in what? X. So if we change x by 1, what will be the corresponding change in y? So let's take for example y is equal to 2x. If x is equal to 1, our y will be equal to 2 times 1, which will give us 2. Now when x is 2, our y will be 2 times 2, which will give us 4. So when there is a change in x, there is what? A corresponding change in y. So this change refers to what? The slope. So when you have gradients in algebra or elementary mass is given by change in y over a corresponding change in x. So that change in y as a result of a change in x. So if you look at price and quantity, whenever price changes, quantity will also change. Either it will go, quantity will be up or down. So that change is what you're talking about. So if you look at differentiation, they have a symbol dy dx. So this one is a change in y with respect to change in x, or y changes as x changes. So dy dx is a change in y as a result of a change in x. Good. So when we have this, we can now move on for general rules of calculus. So we are looking at the general rules of calculus. So rules of differentiation. Good. So let's say we have y is equal to x raised to power n. So our dy dx will be given by n raised to power x n minus 1. What you must note is that always we multiply the power by the whole function, by the function we are differentiating. Then you subtract 1. So you should take note that the power times the function, the power minus 1. The power times the function, the power minus 1. So let's take a few examples. Let's say we have y is equal to s cubed. So the power here is what? Dy dx is 3. So it will be 3s cubed and that power minus 1. So it becomes 3s squared. Another example, if we have y is equal to 4x squared. So our dy dx will be equal to, our power is what, 2, so that 2 times 4x squared minus 1, so it will be what, 8x. So the power is what, 2. It will come and multiply here, and the power minus 1. So let's take a bit difficult one. Y is equal to 8x squared plus 4x plus 5. So our dy over dx, we do term by term. So here the power is 2. So 2 times 8x squared. So this minus 1. And here the power is 1. So it will be what? 1 times 4x. And this one has no power. So it will become what? 0. So when we simplify it, 2 times 8 will be 16x plus, this one will give us 1 minus 1. So it will be what? 4. Now we have to take note. When we are differentiating calculus, any number without a letter or variable like a, x, y, and so forth, it should be equal to 0. Don't even write it. That is 1. 2. Anytime we are differentiating and the power of the number or the variable is 1, you write the number behind the variable. For example, 4x. Don't even differentiate, just write 4. Let's say we have 10x. When you differentiate, it will be 10. Don't write it. Let's say we have 20p. It will be 20. Don't even differentiate. So take note of these things. Then it will help you to move very quick. So let's take another example. This one we are looking at fraction 1. So when you have y is equal to 1 over 3 s cubed plus 1 over 2 s squared plus x plus 5, we have to differentiate. So to be dy dx, where is the power is 3, so 3 times 1 over 3x, the same thing, 3 minus 1, plus this one, where is the power, so it's 2, so 2 times 1 over 2 s2 minus 1. Then we come here the power is 1, so the number behind it is 1, so you write 1. Any number, the coefficient of it is 1. Any variable, the coefficient is 1, like a, yes, it's equal to 1a. P is 1p, 1 is here. C, 1 is there, so you write 1. Then this one is having no variable, so it will be 0. You leave it. So now let's simplify. 3 will cancel here, making s squared, because 3 minus 1 is 2, plus this 2 cancel this 2. Then 2 minus 1 is 1, so it will be what? X. And any number raised power 1 is the same as that number. So we have this as the function. Now let's take example under, this is example 1, example 2. Let's say we have q is equal to p squared plus 2p. So we are differentiating this to be dq over dp. So the power is what? 2p, the power minus 1. But this one, because it's what? Doesn't have any power, it's 1, so it will be what? 2. So we'll get 2p plus 2. So we should take note of these things. So let's now start and apply these differentiations. So we are looking at applications of differentiation. So application. So differentiation is always refers to change. So change. So because it's change in business, we can apply it in marginal revenue, marginal cost, marginal profit, marginal product of labor and capital. We can apply to also to profit maximization. So when we have been given a question, then you see find marginal revenue, marginal cost, marginal profit, marginal product of labor or capital, profit maximization, then you have to use calculus differentiation. So let's get some few understanding of this concept. First one, let's look at total cost. So total cost is total fixed cost plus total variable cost. And the fixed costs are the costs that you incur on fixed input. Okay, so total fixed cost is the cost that we have to incur on fixed input. So the fixed input are those items that we buy which cannot be changed in the short run, like land, equipment, then plant that we use for production. And the variable input are the costs on the variable items for production. For example, if someone is operating a chalk bar, the person may need land or rent. The person may rent, also may buy some saucepan and other things that be used for production of the fufu. But the person may also need some money for buying of cassava, meat, paying of the laborers and the rest. These are the variable inputs. So the cost on those items are the total variable costs. Good. So then total cost can also be average cost times quantity. So when they give you average cost, you just multiply it by quantity to get what? Total cost. Total cost can also be unit cost times quantity sold. It can also be unit cost times quantity sold. So to get marginal cost is changing total cost over changing quantity or output. So this means you can apply calculus. So it's dTc over dQ, change in total cost over change in quantity, and this we use differentiation. So the change in understanding is that total cost 1 minus total cost 2 all over quantity 1 minus quantity 2. But here we are interested with the calculus. So to find marginal cost, we use calculus to do it. Good. So let's now take another one, which is this is the first one, total cost. We now move on to total revenue. And total revenue is price times quantity. So the total revenue is also referred to as total sales. Let's look at this. If you are in a shop and you are selling, if you're able to sell 20 items, this is 20 phones, and each phone costs 100 cedis, your total revenue will be 20 times the 100, which will be 2,000 cedis at that moment. So that is the total revenue. So to find marginal revenue is simply changing total revenue as a result of a change in quantity. Good. So let's look at the calculus version of the marginal revenue. So let's look at marginal revenue. So marginal revenue, we said, is changing total revenue over changing quantity. So it means total revenue 1 minus total revenue 0 over quantity 1 minus quantity 0. It means that the new revenue minus old revenue over new quantity minus old quantity, that is the meaning. So in calculus, marginal revenue will be the total revenue, the quantity. This will give us marginal revenue. So let's now go to the third one, which is profit. And profit is total revenue minus total cost. Then we have marginal profit will also give us the total profit over the quantity. Good. So when you are giving profit, we can differentiate profit to get marginal profit, which is a change in profit as a result of a unit change in output. So let's look at profit maximization. So in business, profit is maximized where marginal revenue is equal to marginal cost. So when you are given such a question, you find marginal revenue, you find marginal cost, then you equate it to solve. It is also refers to break even point. Break even point. So when you are asked to find break even point, it means this is how you must solve it. So let's now go through examples of them. So let's check an example. Example 1. So let's say we have cost function is equal to TC equal to 100 plus 2K squared. Then we have revenue function to be 25 plus 100 plus 10K squared. Good. So we have this function. We are asked to find total cost at Q is equal to, let's say, 10. Then we have to find total revenue at output of 5. Good. So what we need to do is that we have to write total cost is equal to 100 plus 2K squared. So now we have to find total cost of 10 output. So where we see K, we put 10 there. So it will be 100 plus 2 times 10, which is Q square. And square means the number times itself. So with this one, you use calculator, point the same thing on the calculator and write your answer. So it will be 300. It will be 300. So this will be 100, and 100 times 2 will be 200, plus 100 will be 300. Good. Then total revenue at 5, quantity of 5. So it will be 25 plus 10 times 5 square. So you point this whole thing on your calculator, whatever you get, write the answer. Make sure you point it well. So 5 square is 25. 25 times 10 is 250. So it will be 275. Good. So this will be our revenue and cost. Now, with the same question, we have to find marginal cost function. Marginal cost function. So it's equal to the total cost over the Q. So let's go. The total cost, the Q. I told you that when we have a number without a variable, it's 0, so you don't write anything, so you differentiate this one. So the power is 2, so the 2 times 2 Q square and minus 1. So this will give us 4Q, because 2 minus 1 will give us 1. Any number raised to power 1 is the same as the number. Then we have to find marginal revenue function, which will be the total revenue dq. So this one too, there's no variable, so it will be 0. You don't write anything. But this one, you differentiate this one, so it will be, the power is 2, so it will be 2 times 10 Q raised to power 2 minus 1. So you get 20 Q. 2 minus 1 is what? Is 1. So you leave it the same. So we can be asked to find profit function. Profit function, which will be total cost minus total revenue. So this one, we total revenue minus total cost, rather total revenue minus total cost. So let's see. So profits will be equal to total revenue is 25 plus 100 Q square, then minus, you put bracket here, total cost, which is 100 plus 2 Q square. Then you start, you group them. This 25 is a whole number with 100, so you solve this. 25 minus 100 minus 75, then 100 minus 2 will be minus 98 Q square. Okay, so we are to solve for the profit function. So profit is equal to total revenue minus total cost. So profit will be total revenue is 25 plus 10 Q square minus total cost, which is 100 plus 2 Q square. So when we get this number 25 corresponds to this 100, so you subtract this 25 minus 100, use calculator, use punch it, 25 minus 100 to give you minus 75. Then 10 minus 2 will give you minus 8 Q square. So when you only subtract the number behind the variable, 10 minus 2. So this will be the profit function, profit. So if you're asked to find marginal profit, so you differentiate, so to be the profit over the Q. Good. So this one is without a variable, so ignore it. So differentiate this. So the power is what? 2 times minus 8 Q. The power is what? 2 minus 1. So get minus 16 Q. Minus 16 Q will be the profit function. So let's look at how the firm will maximize its profit. How it will maximize its profit. So we will look at that one. So but let's put this one here so that when we come back, we will be able to know what we got. The marginal revenue was 20 Q. Good. So we are now looking at profit maximization. So profit will maximize where marginal revenue is got marginal cost. So our marginal revenue is 20 Q. Marginal cost is 4 Q. So our profit will maximize where 20 Q is equal to 4 Q. So we set it to be 20 Q minus 4 Q is equal to 0. So we now get minus 16 Q. So you see that profit, it is same as the marginal profit that we obtain. So this is the function. So we will continue solve more examples in our next video. So keep on watching, subscribe and share to people who may need this video. So thank you.